Welcome to today's ABC-UTC Research Seminar. The presentations in these seminars highlight research work at the ABC-UTC partner universities. Each seminar consists of a 40-minute presentation followed by a 15-minute question and answer session. My name is Mary Lou Rawls-Newman, Director of Technology Transfer at the ABC-UTC. I'll be moderating today's seminar. I'll be assisted by Paul Lyles, former Georgia State Bridge engineer, and Jugesh Kapoor, former Washington State Bridge engineer, and now with WSP USA, both members of the ABC-UTC Advisory Committee, who will be moderating the Q&A session. Rachel Jenkins, ABC-UTC coordinator, will be managing the web room. We're pleased to welcome participants at 485 registered sites for today's seminar. The seminar today features the ABC-UTC research project on critical impacting factors and trends on bridge design, construction, and operation for future planning, conducted at Florida International University. I would like to thank Armin Marabi, co-director and director of research at the ABC-UTC, for coordinating today's featured research project. We're pleased to introduce our presenters, Zhang, principal investigator, and Maruf Muhaimin, master's student on the project. Lou?
Hello, everyone. My name is Zhang. I am assistant professor at Master Department of Construction Management at Florida International University. And I am here with my student, Maruf Muhaimin. Maruf graduated with a master's degree in construction management in summer 2021. And he is now a project engineer at Lunacon Construction Group. We are glad that we have this opportunity to talk about our research on critical impacting factors and trends on bridge design, construction, and operation for future planning. And in our presentation today, I'm going to first give you a brief overview about our project, and then I'm going to pass the time to my student so he can continue to talk about the details of the methodology and results of the project. All right. So let me start my presentation with somehow unpleasant fact. Well, we know that the infrastructure systems in the US are not in a very good shape. They are deteriorating. And a large number of bridges require major rehabilitation and significant reinvestments. And just this morning, we read the news about the bridge collapse in Pittsburgh. And according to a report published by ASCD, there are currently 46,100 structurally deficient bridges across the country. And it would take 50 years to fix them all based on our current investment rate. And when we reinvest on these bridges, if we continue to use the same processes, practices, technologies, and materials that were developed in the 20th century, then more likely we'll still see the same results coming up. So at this moment, we really need a paradigm shift in terms of how this nation thinks about, builds, operates, and invests in infrastructure systems. So a paradigm that can bring more information and more stakeholders to the table, so we can make use of innovative methods and technologies and adapt to the future environmental, social, economic, and technological trends. So to make this paradigm shift happen, first of all, we want to understand the different factors and trends that could affect the future of our bridges. And this kind of understanding is quite important for the transportation agencies and decision makers so they can become more proactive to the changes and to be able to account for the impacts of these factors in their future planning. And in our project, we define critical impacting factors as those factors that may be considered lacking refinement, relatively unknown, but have the potential to affect bridge design, construction, and operation in the short or long term. And some examples of the critical impacting factors are connected and automated vehicles, like extreme weather events, funding availability issues, lack of skilled workforce, or new construction materials or technologies. So as you can see, these factors are from quite diverse areas, and they are occurring and evolving in a fast pace. Also, more and more researchers and policymakers they start to realize these factors could really reshape the way that our bridges are being developed over the next decades. So currently, we don't have a very good understanding about these changes and how they will affect our bridges. This is because we have two major challenges here. First of all, it's difficult to predict the trends of these factors. We don't know whether some factors will be a long-term lasting force or just a temporary phenomenon. And also, it's difficult to understand the interplay between these factors and bridge design, construction, and operation. So to address this knowledge gap in our project, first of all, we want to identify these critical impacting factors, and then we examine how these factors will likely to affect the way that our bridges are designed, constructed, and operated. So we have four major research tasks here, including, first of all, we want to identify all the potential critical impacting factors. And then we want to understand the impacting mechanisms of these factors on the bridges. And then we systematically evaluate how likely these factors will impact bridges. And then eventually we provide recommendations to decision makers. So I'm going to pass to Maruf so he can continue to talk about the methodology and results of our project.
Hello, everyone. This is Maruf, and I will continue from here, and I would like to talk about the methodology and results of our project. So first of all, I'd like to give you a brief overview about the methodology of our project. So we started the project with a comprehensive literature review to identify the potential impacting factors on bridge design, construction, and operation. We then conducted a series of in-depth interviews with bridge experts so we can further identify the critical impacting factors and understand their impacting mechanisms. After that, we compiled our list of critical impacting factors and included them in an expert survey, and we asked the experts to systematically assess the likelihood of impacts of these factors on bridges. We also analyzed the trends of these factors based on expert opinions. Now I will talk about each of our research tasks in more details. Our comprehensive literature review focuses on multiple domains, including impacts of technological trends on bridges, effect of environmental and climate change on bridge structures, and potential social economic factors of bridges. After the comprehensive literature review, we conducted a semi-structured interview, which was designed to solicit experts' opinions on potential impacting factors of bridges. We were able to interview 21 bridge domain experts through 19 face-to-face interview sessions back in December 2019. These experts were from state DOTs and government-owned transportation agencies. And we recorded these interview sessions, and then we transcribed these recordings through a transcription software called Sonic. And we analyzed these transcripts using NVivo. Now, NVivo is a tool used for qualitative analysis of documents, literatures, and surveys. So based on our literature review and expert interview, we were able to identify a total of 32 factors. We made a comprehensive list of these factors. As you can see from this chart, we classified these factors into 4 main categories, including technological, environmental, social, and economic factors. The list is color-coded because we wanted to show from which source they were identified. The blue ones are only mentioned by interviewees, whereas the green ones are only found in literatures. And the light golden ones are found from both the literatures and the interviewees. For example, climate change is both found in literatures and it was discussed in details in the interviews. For the 3 sub-factors of climate change, change in temperature and change in precipitation were mentioned by many interviewees, and it was also found in literatures. Whereas change in relative humidity was only extracted from the literatures. After identifying the critical impacting factors, we further analyzed the impacting mechanisms of these factors on bridges. So based on the interview data, we ranked these factors based on the percentage of interviews who discussed or emphasized each of these factors. For example, we have adoption of new construction materials or structures at 95%, which means 95% of the interviewees discussed about the impact of new construction materials on bridges. This figure here only shows a part of the results with the top two factors in each major categories. For example, climate change and sea level rise have the highest percentages in environmental factors category. Similarly, public-private partnership and change in fuel prices have the highest percentages in economic factors category. Now I'm going to discuss some of these factors which are mentioned in the previous slide. For example, one of the mostly emphasized factors is adoption of new construction materials or structures. For many of our interviewees have discussed that about the impact of these new materials. For example, high performance steel and ultra high performance concrete. As we know, corrosion is a major concern for long-term durability and structural integrity of steel components of bridges. So over the last decades, new materials such as corrosion-resistant rebars or ultra-high performance concrete have been introduced to protect the bridges against corrosion. And besides these, there are some new advanced materials that show promising results. For example, FHWA is currently studying the use of nanomaterial enhanced coating materials that could be easily and quickly applied to steel structures. And many experts mention that these new materials offer a lot of opportunities for our bridges and could even possibly change the design standards of bridges. For example, as mentioned by a bridge engineer from Arizona DOT, he said that we can build longer spans that allows us to eliminate foundations in the water. He also added that we are already seeing the benefits of using new types of materials. The second highest ranked technological factor is new transportation facilities or methods. Some examples of new transportation facilities include connected and autonomous vehicles, shared mobility, urban transport pod, hyperloop, and maglev train. So 90% of the experts agreed that adoption of new transportation facilities would lead to revision of design codes of bridges. For example, automated freight vehicles have the potential for platooning, which involves two or more vehicles connected with vehicle-to-vehicle communication, allowing them to effectively operate as a single unit. This will reduce the headway between vehicles, so it can free up more road space and improve traffic flow. But for bridges, this may become a new challenge. Some interviewees pointed out that this will specifically affect long-span bridges because the current loading models used for bridge design assume that there will be a dilution of heavy vehicles by light vans and cars. But platooning could potentially invalidate these assumptions by creating large blocks that include only heavy vehicles. So we need to consider whether the load models used in the design of structures would be adequate for this change or not. Climate change. Climate change is also a highly ranked factor. In general, climate change has a negative impact on bridges and it affects bridges in different ways. For example, climate change results in more flooding events. As mentioned by one of the bridge engineers from Colorado DOT, the increased risk of flooding on bridges could even lead to total submersion of some of the old bridges in the coastal regions of United States. Another important issue is the frequent flooding that raises the scouring rates, which is a common triggering event for bridge failure. Another critical factor is the change in labor market. This was mentioned by the interviewees as labor shortage problems. The interviewees anticipate that if the shortage is not addressed soon, the productivity, safety, and cost of construction and maintenance works on bridges will severely be affected. According to a survey done by Association of General Contractors in America, 80% of the construction firms are unable to find skilled labor that they require. The labor shortages issues have become more of a problem when it comes into a combined effect with extreme weather events. For example, after Hurricane Michael, because of labor shortage, the damaged infrastructure that used to take 3 to 4 months to rebuild now take 6 to 8 months. In our interview with a bridge contractor, he mentioned we need to reach out to high school kids to spread the information and provide training. We need to build the positive image of bridge industry and bring more labor into this industry. Public-private partnerships, or we call it P3, is another highly ranked factor. 86% of the interviewees discussed about public-private partnerships as one of the new funding sources for bridge projects. Typically, in a P3 project, a government agency contracts with one or more private partners to construct, operate, or maintain a bridge. Now, because of limitations on public funding resources, P3 funded bridge projects are gaining more popularity. P3 projects has several benefits such as efficient and easy financing for projects, reducing the demands on existing public funds, accelerating bridge project schedule, transferring risks from taxpayers to private sectors, and facilitating on-time project delivery. P3 can often motivate private partners to come up with innovative and improved methods to meet project requirements. For example, an engineer from Washington DOT mentioned a hidden benefit of P3 is that it can potentially increase project quality and reduce maintenance needs by engaging the same private partners in both the construction and future operations and maintenance of bridges. After conducting our expert interviews, we included the 32 impacting factors in a questionnaire survey so that we can further solicit expert opinions. This survey has 3 sections, which are impact assessment of factors, trend analysis of the factors, and background information of the respondents. The survey was conducted through Qualtrics from April 2020 to October 2020. And now, Qualtrics is an online software for designing and conducting surveys. So we sent the survey invitations to bridge experts who work in government agencies, private sectors, and academia. And we received 108 completed responses. We have a response rate of 17%. And 76% of our respondents are from government agencies, such as state duties, AASHTO, FHWA. And 15% of the respondents are from academia, including university faculties and researchers. And the rest 9% is from private sectors. When we were analyzing the survey results, we tried to find answers to some of these research questions. The first one is, how likely will each of the factors impact bridges in the future? And what are the future trends of the impacting factors based on the experts' opinions? And what are the factors that are most impactful and most likely to happen? And lastly, do different groups of experts have different opinions on the importance of critical impacting factors? Now, these groups of experts were based on their job position, based on their years of experience and regions where they lived. So, as you can see, this is a bar chart, and it shows the mean indexing of the factors based on their likelihood of impacts. As you can see, some of the top-ranked factors come from economic categories, including availability of funding and change in construction costs. Economic factors are actually critical for bridge reinvestment. They directly determine whether it would be feasible to move forward with some projects or not. In the United States, bridges are typically funded by federal aid highway program. Taxes and fees that include general taxes and tolls collected at expressway and bridges, and private investors from P3 projects. We found out that the Highway Trust Fund has been on the brink of insolvency for 12 years, which creates a lot of uncertainties for state and local governments to finance the bridge projects. Some recent trends, for example, the government signed an infrastructure bill of $1.2 trillion, and 40 billion of it is planned for bridge repair, replacement, and rehabilitation. This may help address the funding availability issues. Other top-ranked factors include change in intensity and frequency of extreme events, adoption of new construction materials or structures, and adoption of new construction techniques. You can also see the average mean indexing of 4 main categories are listed in the small table to the right. Collectively, technological factors have the highest impacts. In recent decades, there are many new technologies being introduced into the infrastructure sectors, including technologies that are going to directly affect the ways our bridges are designed and built. For example, in our previous interviews, many interviewees mentioned that by using new materials and construction techniques, the bridge standards can be potentially changed. We also analyze the potential change in trends of these factors based on expert opinion. From this chart, we can see most of these trends will continue, while there is one factor, which is a change in fuel price. We saw a reverse trend according to survey results. So when this survey was conducted, there was a drastic fall in fuel prices. So the results suggested that the fuel prices will rise again, which has actually happened. We all have seen a rise in recent fuel prices. So latest information from Energy Information Administration show that there is on an average an $1 rise per gallon in fuel prices throughout the country compared to prices from a year ago. Though it is a fluctuating factor, it has impacts on gas taxes, travel demands, and construction costs. For example, the maintenance and rehabilitation of our nation's bridges are supported by federal gas taxes. And we can also see that most of the technological factors have higher trend rating. This result coincides with the rise in use of different new technologies in bridge design, construction, and operations. So we also developed a scatter chart to plot the integrated results of both likelihood of impacts and future trends of the factors. On top right corner, you can see these are the factors that are both likely to happen and causing high impacts on bridges. And these factors are adoption of new construction techniques, adoption of new construction materials, change in intensity and frequency of extreme events, and change in construction costs. For example, research shows that in recent years, construction cost is changing due to rise in material prices, labor costs, change in construction management methods, use of new materials and technologies, and flow of construction resources. And currently, we are facing a global supply chain issues, which also heavily impacted construction material prices. We see some vendors and contractors are facing difficulties in supplying and performing due to rise in material prices. Also, just recently, we know that there is an issue of inflation, which may also impact construction costs. We can also see an outlier here, which is F27. It is availability of funding. This factor is the most impactful factor, and it has a moderate continuous trend. This moderate continuous trend is mostly because of there are quite a lot of uncertainties involved in availability of funding. On the other hand, due to COVID-19, the state DOTs were facing an average revenue decline of 30% over the pandemic. Also, the Federal Highway Trust Fund posted more than 50% decline of receipts in September 2020 compared to September 2019. But as we mentioned, some recent trends, for example, the infrastructure bill, may also help address funding availability issues. In the middle part, you can see many of these factors are clustered here in this area. This area includes factors like sea level rise, change in labor market, public-private partnership trend, change in ways of management and communication, change in safety requirements. So these factors have moderate to high impact with high possibility of continuous trend. For example, change in ways of management and communication actually has the highest mean train rating among all the factors. We found some digital technologies such as bridge information modeling, BRIM, cloud-based management software tools, Procore or Penta, and digital supply chain management platforms such as Oracle or JDA. They are being adopted in bridge and infrastructure sector and may change the way future projects are delivered. And now to the left lower area, these factors are the ones with lower impact and moderate possibilities of continuing trend. They are changing socioeconomic status, change in perception on carriers, change in water quality. At the bottom, we can see another outlier with a negative trend rating. As we have mentioned earlier, this factor is changes in fuel prices. It has a moderate impact rating because gas tax is a major source of funding bridge projects. So the overall idea is that this chart can potentially offer insights to our practitioners, given that when there is limited funds, we may want to focus on the factors that have high impact rating and higher possibility of continuous trend. In task 3, we also tried to find answers for our fourth research question, which is, do different groups of experts have different opinions on the importance of critical impacting factors? So we performed a set of statistical analysis to identify the factors that were rated significantly differently across different groups of experts. We formed groups among the survey participants based on their job positions, years of experience related to bridge, and regions where they resided. As you can see from the chart to the right, the 3 groups that were formed based on job positions are academic researchers, construction and maintenance engineers, and design engineers. Similarly, 4 groups were formed based on years of experience, which are 1 to 10 years of experience, 11 to 20 years of experience, then 21 to 30, and lastly, above 30 years of experience. And then 2 groups were formed based on regions, which are experts who are from coastline states and experts from states with no coastlines. We conducted Man-Whitney test on the 2 groups of regions. And we performed Kruskal-Wallis H tests and pairwise comparisons among the groups of job positions and groups based on years of experience. Here we are showing the summary of the results from our statistical analysis. So for groups of job positions, we found 5 factors were rated significantly differently across design engineers, construction and maintenance engineers, and academic researchers. As you can see from the bar chart, the academic researchers have significantly high ratings on all these factors. We have found 3 environmental factors that were rated higher by academic researchers in this analysis. This result is consistent with some other studies that shows climate change or other environmental issues receive higher levels of concerns across the academic researchers. For the technological trend, new transportation facilities or methods were rated significantly higher by design engineers than by construction engineers. This may be because the impacts of new transportation facilities such as connected autonomous vehicles will require potential change in design standards of bridges, which are now being dealt by the design engineers. On the other hand, you can see construction engineers have higher rating on advancement in structural health monitoring techniques. This is because our construction and maintenance engineers, they have shown increasing interest in using these techniques. For example, drones, computer visions, or machine learning techniques. And of course, there is a lot of research going on in each of these areas. So that's why you can see higher ratings from researchers as well. In terms of years of experience, we can see a generational difference on environmental factors. Bridge professionals with less years of experience have significantly higher ratings on change in temperature, change in relative humidity, and change in water quality. This result is consistent with a number of studies that show there are significantly differences in perception of environmental factors and climate change among 4 existing generations, which are baby boomers, Generation X, Generation Y, and Z. Younger Americans are more concerned about the impacts of climate change than older adults. Some studies also show that younger populations also feel more responsibility to take actions to reduce global warming. For this chart, it shows sea level rise and changes in legislation and policies were rated significantly differently between experts from states with coastlines and experts from states without coastlines. Now, sea level rise has been posing major threats to low-lying coastal communities, including bridges in these communities. According to an interview with one of the experts, the old bridges which were built before 1980s and are located over coastal streams need to be replaced within 35 to 50 years. This is due to rising water levels in coastal streams during tidal activities. Because of rising water levels, old bridges will be left with less than required clearance underneath the decks, where salt water could cause severe corrosion in the bridge bearings and compromise the structural integrity of these bridges. This result also shows some consistency with a study that says that the stakeholders of infrastructure in the inland or landlocked states are more likely to ignore the impacts of sea level rise and climate change. Also, coastal states are more likely to introduce legislation and policies for their infrastructure in a way that is more adapted to climate change. Also, coastline states have more economic activities, which means they have more dense infrastructure network. And this might also affect the legislation and policies introduced in these regions. So in our interviewees also mentioned some actions or strategies that we can take to adapt to some of these technological, environmental, social, and economic factors. So for technological factors, adoption of new construction materials is critical to increase the life expectancy and reduce maintenance needs. But high initial costs could become a primary barrier for adopting these advanced materials. So to address this situation, some interviews recommended the use of top-down approach. Now, a top-down approach requires the higher administrative level policymakers to support industry research on new materials or technique adoption. Also, the interviewees recommend more research on the life cycle cost analysis for new materials because this knowledge could provide evidence for demonstrating the long-term economic advantage for using new materials. The result of these analyses can be included in material purchase standards to facilitate best value purchases. In addition, when we integrate new technologies into the bridge sector, there is a need for multi-sector stakeholder collaboration that engages government agencies, private industries, and multidisciplinary researchers so that we can comprehensively facilitate the development and deployment of new technologies from both technical and policymaking perspectives. Now, moving on to environmental factors, our interviewees suggested we want to constantly reevaluate our design standards or building codes so that we can update them accordingly and make them more adaptive to changes in climate and rising sea levels. Also, the use of new materials that we just discussed could allow these structures to be more durable and resistant to environmental impacts. And some new techniques such as ABC could reduce the impacts of bridge construction on the environment. And additionally, we want to consider multiple retrofitting strategies to better control the impact of environmental changes on bridges. We also need more research on these strategies such as cost-benefit analysis or life cycle analysis so that we know which one to implement and when to implement. So in terms of social factors, we need to better educate and uplift the technical skills of our current workforce. We want to offer more training and education about the new technologies to our workforce. For example, training on bridge information modeling and new bridge structural health monitoring techniques. Also, construction safety is a major concern in bridge industry. The interviewees suggested that new bridge construction techniques such as ABC can potentially improve the safety of construction processes. Now, these techniques can reduce hazard exposure time and area, and they could also improve productivity. They can also improve overall societal perception on bridge construction as they cause minimal disruption to regular activities. For economic factors, according to our interviewees, we want to better standardize some project financing programs such as P3, for example, how to determine if P3 is appropriate for a project, how to develop a comprehensive request for proposals for P3 projects, and how to decide which proposal to accept. Also, to cope with budget concerns, state and local transportation agencies may need to reevaluate their typical project planning and programming policies to better align funding with decision making, so that we can achieve the best and highest use of infrastructure assets and revenues and provide cost-effective solutions to current and future transportation needs. The interviewees also recommend we need to systematically integrate economic considerations into project planning and evaluation processes. So we want to evaluate the economic impacts of bridge projects, and we may want to prioritize bridge projects that support the local economy, create new jobs, and improve social welfare that leads to increases in local tax revenues. Now I will pass back to my advisor so that she can conclude our presentation.
All right. Thank you, Maruf. Well, to conclude, today, my student and I, we presented our research project that focuses on exploring the impacts of critical impacting factors on bridges. We conducted expert interviews, surveys, and literature review. So this research has the potential to offer some great benefits to our transportation agencies and decision makers. Our research offers the holistic understanding of these factors from multiple areas, and this can allow our decision makers and policymakers to become more proactive to the changes so they can introduce more adaptive and timely standards, regulations, and policies that can address the new challenges brought by these factors. And for example, based on what we find out from this project, our decision makers can prioritize their actions by focusing on those factors that are most likely to happen and likely to cause significant impacts. And the findings from this study can also offer some insights and drive a rethinking of how we can better manage or invest our bridge assets in a way that prepares for some of the inevitable technological, environmental, social, and economic changes. And in terms of the future work, Well, for our project, because it was launched in September 2019, and for example, we did our interviews in December 2019, and we did the expert survey in summer 2020. So we do realize there are many new factors and trends that are happening after then. For example, the COVID-19 pandemic and the recently passed infrastructure bill, and also the inflation that everyone is talking about now. So we believe these factors, whether they are long-lasting trends or just short-term phenomenon, they will impact or are already impacting our bridges in different ways. So we think, given there are many things that are changing so dramatically in these years, we may want to continue this research by further investigating the new factors that are showing up. Also, in our future work, we may also consider reaching out to experts from different areas, not only in the bridge area, but also economic, social science, so they can share their knowledge and expertise about some specific factors or trends. And also for each of these factors that we have already identified through our project, we believe there is a need for further analysis. We think our work is a good starting point because we try to analyze these factors in a comprehensive manner by learning or summarizing the knowledge and experience shared by our bridge practitioners and experts. But to offer more data-based knowledge, we need to further investigate each of these factors by collecting more data and conducting further analysis. For example, like the factors we identified, like sea level rise or changing construction costs, we need to have those real numbers to offer more concrete recommendations. And I also believe, our transportation agencies also need this type of data and research to support their future decisions. So from this perspective, we think this project really opens doors for many potential research directions in the future. And we are glad to see some of this research is already ongoing and is already bringing benefits to the practical world. So in the end, we would like to acknowledge the support by the Accelerated Bridge Construction University Transportation Center, ABCUTC, and thank you everyone for attending our seminar today, and we are happy to answer any questions you may have.
Thanks to Lou and Maruf today for your interesting and informative presentation. Paul and Jugesh will now moderate the Q&A session. Paul?
Thank you, Mary Lou. And yes, we do have a few questions that came in beforehand, and we've got a couple that have come in during the presentation, and hopefully we'll have a few more in a few more minutes as we get into answering the questions. But we'll go ahead and get into the questions. So the first question we have, and we get this quite often, but what is the consideration of contractor claims, weather or supply chain delays, and maybe steel costs on bridge design, construction, and operations?
Yeah, so basically, thank you so much for the question. And I do work in a general contracting firm. So from the perspective of this research, we think that these factors could be the short-term affecting factors, and these needs to be taken in account. But also we do have to see what are the long-term factors that are affecting our bridge design, our bridge construction and operations. But I would say that considering the claims or the costs of increasing costs of materials that's happening, that we have already addressed in our presentation today, these do put a lot of impact on bridge construction and bridge maintenance works, and overall in the construction industry. And we do have to take these into account from time to time, so that that's why we also mentioned that we have to keep on re-evaluating our impacting factors, and also keep searching for factors that might be short-term, could be long-term. So.
All right.
Okay. Yeah.
Maybe I can just add a few points. So I think this is really related to one of the factors we discussed in our presentation today. It's about the construction cost. Because the supply chain delay, that's also going to raise the construction cost, right? The material price and other labor cost issues. So we do see that trend, that construction costs going up. So I think in the short term, from short-term perspective, this rising construction cost can cause some challenges for our state and local governments to finance the really needed bridge projects. And this can also complicate some long-term planning for the new bridges and potentially, delay the repair and rehabilitation of current, those bridges that are in critical conditions. And state governments, they may be able to, they may possibly, seek other potential funding sources as well, like maybe through involving private sector, like the P3 we mentioned in our presentation earlier. And from long-term perspective, this is just some of my own opinions. Okay, so it's I think this maybe also opens some door for those our transportation agencies to consider the use of those new technologies or tools or materials. We know that they have like a bit higher initial cost, but from long-term perspective, they may also offer some great cost benefits, like life cycle cost benefit to our agency. So I think that could be, so there's pro and con for these kind of situation.
Okay. Here's one that came in beforehand, before the presentation. It says, could you discuss artificial intelligence and/or machine learning in relation to bridge management best practices?
Yeah, I think there is a use of AI, or there is a growing research and also implementation when it comes to AI or machine learning techniques. Especially, I think in construction safety overall, there is a computer vision technology such as computer vision is being implemented, where you can identify workers' safety by using AI to see that if the worker is in any kind of danger, or is in a safety area or in a danger area, is he doing any kind of mistakes or not. So yes, there is a implementation of AI and machine learning techniques in both, I think, in both design and in construction, and also in construction work. From design perspective, we see that there is a lot of implementation of BIM, but BIM is getting more, evolved. There is ongoing research on BIM to how to put more, how to make machine-based decisions or AI decisions, how to implement AI into making decisions in design rather than involving human decisions. So we are seeing some very good research in this field when it comes to construction, and hopefully in bridge we have BRIM, and I hope that as BIM evolves, bridge information modeling, which is BRIM, also evolves with that. So I do see a lot of potential in future when it comes to AI or machine learning in bridge construction.
Okay.
All right. Sorry, I think I can also just add a few points. I am thinking, for machine learning or AI, I think before we start to talk about machine learning or AI, maybe the first thing we want to discuss about is the data, because that's really the starting point. That's machine learning of what? We are analyzing our data and try to extract knowledge out of the data. So I think before we even move forward to talk about those applications, we first need to think about the quality of the data or data governance problem, because a lot of time what we see is, from DOT's perspective, we do have those data, right? Those data are there, but we are not quite take full use of them, like full advantage of them. And another big issue is, we think we have a lot of data, because I think in bridge area, we already do a great job. We have our, national bridge inventory that has a lot of data in there, many different types of data. And the DOTs are kind of collecting and submitting these data on a annual basis, right? So we have already done a great job. But the problem is there are other potential data that are still buried in there, right? We know we already have some good data. These are structured data, but there are still some unstructured data that are still buried there. For example, like the data in the inspection reports or construction documents. They came in an unstructured manner. By unstructured, what I mean, they are in like PDF version, they are in Word documents, they are natural languages, they are not those like beautifully stored in database, right? And we also saw those image data, right? Like there are many pictures taken during the inspection process, and we saw those data that are also in those inspection reports. So there are many different types of data, and some of those are unstructured. How can we better make use of these data? Right. So currently, we have better technologies or machine learning, or AI techniques, for example, like computer vision that my student was just talking about, and also natural language processing that deals with text data, right? But the first thing is we need to kind of look back into all those data we already have and try to think about how we can, better extract the useful information from these unstructured data. And another thing, I think a big challenge we see is data integration, because these data are from many different sources. For one bridge, just think about one specific bridge project. You have, for example, construction data. That is, you have the field reports, you have the contract documents, you have the price data, right? So all those information are in a separate source or in a separate office. And now later on, once the bridge is constructed, we also have the inspection data. We have the maintenance schedule, right? So those are in another phase. And I forgot to mention the design data, right? You have the bridge design and those information. So these are all data, but they are in all these different sources. So how can we better link them? How can we better integrate them together? Then, after we have a better data governance or data management, then we can move forward to talk about, AI or machine learning, or what questions we can address through using these data, or what kind of knowledge we can get out of these data. Because, from researchers' perspective, we have those algorithms there, we have those models there, but our data at the beginning really create a kind of challenge for us, right? We need to first manage these data in a better shape, and then we move forward to really make use of the data through those machine learning techniques or AI.
Okay. We have a couple of maintenance type questions that came in ahead of time. Before the presentation that says, can you talk about the impact factors and trends on the bridge maintenance side also?
So basically, the factors that we discussed, they have impacts on bridge design, construction, and also in maintenance and operations. So but to focus on some of the factors, I would say the technological factors, such as different ways of the bridge monitoring system, the new techniques of bridge monitoring systems, they are being implemented, or they have a huge potential of being implemented in bridge maintenance. And we do have to consider, when it comes to some of the economic factors, that when it comes to bridge maintenance, maintaining old bridges, do we implement those economic factors there? For example, P3. Are we going to use any P3 for bridge maintenance or operation, or on which bridge or what kind of project we should implement these economic solutions or economic packages, I would say. Then if we want to discuss about the environmental factors, I would say, as we have mentioned in one of the slides, the chain, because of the environmental factors, because of extreme weather events or extreme environmental effects, sometimes the maintenance of the bridges become very much difficult, or rehabilitation of bridges become very much difficult. We have discussed about the climate change issues and the sea level rise, where these factors actually affect the rehabilitation, the overall rehabilitation of a bridge. So there might be, there are hundreds of bridges that has been that's going to be discarded in the next couple of years because of we don't have a perfect set of solution for these old bridges. But there are some ways to save these bridges. There are some technologies or techniques or adaptation techniques or strategies, or there are some economic, I would say, financial solutions to save these bridges. We just need to implement them. We just need to implement from that has to come down from policymakers and stakeholders of these bridges. So yeah, I don't know, Professor, if you want to add to this.
Well, yeah, I think one thing that you mentioned in the end, I think that's something we definitely want to consider in the future, and in terms of how we want to better adopt those new technologies for different aspects of bridge, perhaps not only bridge maintenance, right? Also bridge design and construction process. We see those new materials and new techniques coming up, but how can we better implement it and better integrate it with our practice? So one thing that we definitely learned from our, from the interviewees who participated in our project, they mentioned, one of the possible approaches is really we need to have perhaps a top-down, or maybe we can call it top-down approach, right? We need to engage our government agency to lead this process, right? So to really try to maybe include some of those new materials or techniques in current bridge design standards or construction specifications. So then this is a way to really push for more adoption and use of these technologies or trends. But of course, it shouldn't be only from the government side. We really want to have a multi-stakeholder collaboration in this process. We should have the private industries involved. We need to have our academic researchers involved. So we want to have these different parties to collaborate in this process, so we can better adopt those factors, or new technologies for bridge design, construction, and also maintenance, I think.
Okay, we have another maintenance question. Says, did you consider how each agency approaches maintenance of bridges as either proactive or reactive when formulating your conclusions?
I think what we considered is that we suggested that we should be, the researchers, people in the industry, the stakeholders and the policymakers should be proactive and use these adaptive strategies for bridge design, construction, and maintenance. Rather than being reactive, we think that being reactive is agencies should change their ways of dealing with, say, if that is bridge maintenance or rehabilitation. Rather than being reactive, we need to be proactive, so that if we design a bridge or construct a bridge, we should be thinking more into the future. And like Dr. Zhang just mentioned, that if we use new construction materials or techniques or technologies, the initial cost will be high. But if we do a life cycle cost analysis, of course, that the total cost of the bridge is going to be lower. So we have to be more proactive. The agency should be more proactive in bridge design, construction, and also in maintenance, so that we don't have to discard any bridge. We don't have to do a major rehabilitation of bridges, so that we can be prepared for any the upcoming environmental changes, social or economic changes.
Okay. There was a question here came in before the presentation. It says, from a bridge construction perspective, what are the biggest quality assurance issues bridge owners are facing today?
I would say because there are hundreds of bridges that are facing failure, I would say the quality assurance issues could be the quality assurance issues could be the condition of those bridges, where we want to rehabilitate or we want to maintain those bridges. We cannot, because there are lack of skilled laborers, there is lack of funding, and hopefully this infrastructure bill kicks in so that we could like do the rehabilitation, the repairs of the bridges in a proper way. But when it comes to quality assurance issues, I'd say that we should implement our new construction materials or the new techniques that we were talking about into maintaining the bridges or construction of bridges, so that we could maintain or better improve our quality of constructing bridges or maintaining bridges.
Okay.
Go
ahead.
Maybe let me just add one more point, just from my own perspective. I think if we are talking about quality assurance, I think a challenge or issue is how can we ensure the long-term quality of these bridges? Because from short-term perspective, we see a lot of bridges are doing just fine, right? All components, all different elements of it, they are doing just fine from short-term perspective, right? Once the project is done, you do the inspection, you check the project, everything looks perfect, and then good, then we have this project, just completed there, right? It's in a very good shape. But how can we better ensure the long-term quality? Because we still see our bridge deteriorate over the years. And for example, if I talk, because I was recently working on this coding related project, and then we are seeing, the coding system for steel bridge, they cannot last as long as the expected service life. So then how can we better ensure this long-term quality? Because by the time these bridges start to deteriorate or some components start to fail, then we cannot hold anyone's responsibility in it. All, from our DOT's perspective, right? So all DOTs can do is, right, we do our regular inspection, and then we find problems, and then we start to fix the problems, and we use our own money, right? So that's kind of the typical practice, but we cannot hold anyone else responsibility in this. But you see in commercial construction or other types of construction, it's very typical we use the warranty system, right? Contractors they have to have a warranty like 1 to 10 years. We see those differences, right? Different lengths of warranty for these projects. We need to guarantee the quality over this certain amount of time. But for infrastructure or bridges, these are kind of rare. I know some DOTs, they are implementing this for some components, like maybe pavement or maybe like coatings. We see, like, for example, Michigan DOT or Wisconsin DOT, they have these kind of warranty systems going on, but not all the DOTs and not for all parts of the bridges. So then I think this could be a kind of challenge for DOT to think about, right? So like, how can we better ensure the long-term quality? What if something happened? For example, if you're talking about coding application, that's a very kind of sophisticated process. If we do something wrong in that process, it really affects the whole performance of the coding. system over a long time, right? Right after the project is completed, you go and check in and you think, okay, everything looks perfect, everything looks fine. But then after a couple years, things start to fall apart. Then by then, what should we do? Right, so I think that this kind of long-term quality is really a huge issue that bridge owners are facing today.
Okay. A couple of material questions real quick. Is low carbon dioxide CO2 emission concrete currently being specified by DOTs, or will it be in the near future?
So I did read about and see that some of the DOTs have been promoting low carbon dioxide concrete. For example, FDOT has their specifications and has their standards on the low carbon emission concrete, and they do promote this. But when it comes to implementing, because these things should be implemented, when it comes to implementing or using it in construction of bridges, that has to come down with much greater encouragement to the industry people, to the contractors, to the private industry, the private sector. So it has to come down from the policymakers, the stakeholders who are in DOTs, in other state government agencies and federal agencies, that you have to give proper encouragement to private sector, to contractors, to vendors, to use it to implement these types of materials into bridge construction and bridge maintenance. I see a lot of work in terms of design standards, in terms of changing the design codes, or there are research academicians are working on these materials, researching how we could implement this. But at the end of the day, we do have to have these materials available to the contractors. We have to have a market for the vendor, so the vendor can bring in this material into the construction, and the contractors could use this material in construction of bridges.
Okay. The other question was, is the use of glass fiber reinforced polymer, GFRP, as a replacement for normal steel reinforcing becoming more accepted by DOTs?
Fiber polymer, fiber reinforced polymer, I would say, yeah, glass fiber reinforced polymer. I would say there is research on it. There is the DOTs are promoting this, but from industry perspective, I don't think this has been implemented in the way it has to be. Like, it hasn't been made popular, and this is the case with all the new materials or new technologies, that we have to find. First of all, we need to make it available in the market. We need to then we need to make the contractors encouraged to use these materials. And the first challenge that the contractors or industry people they face is getting the skilled laborers to handle these materials, to use these materials. So that's a challenge, and that's why we say that there has to be a multi-sector collaboration when it comes to new technologies, when it comes to new materials or new techniques, or that we want to implement in the industry. So it has to be a multi-sector collaboration between federal and government, state and local agencies. It has to be a collaboration with the vendors, the contractors, and also researchers. So I think we are heading to a right direction, where we are using the new materials and techniques, but we have to make it popular among in bridge construction.
Okay, here's one that came in. This is a new question. Has your study or other in the infrastructure considered influence or relationship between the individual factors and how it affects the final recommendation?
Yes, what our study says that in a way it did address some interplay among some of the factors. For example, how we can for example, the effects of climate change and how we can use new technologies or techniques to adopt those bridge structures to face those climate change issues or sea level rise issues. We did study the interplay, and we also also discuss about some economic solutions to bridge problems and different issues that we are facing in bridge. But we do have an understanding of the interplay, but I think we need to do further studies on this to specify or to make a knowledge base that says that which factors or which two factors or which three factors have interplay among themselves, have relations, or we have to specify that relation, we have to find that relation. I would say that this is a part of our future study on this research. Professor, if you want to add something.
Well, I would say, I think the short answer is we accounted for the interplay of these among these different factors, but we didn't do it systematically, or we didn't use a systematic approach to deal with such kind of interaction. But we do, because our study is based on the interview and survey, which means, knowledge shared by our bridge domain practitioners and experts. So we do have many of those interviewees discuss some of those problems. For example, the one that my student just mentioned, climate change and the relation of new technology and new material adoption. Because climate change is going to affect our bridges, but then, we also see we have new materials that can potentially withstand some of the challenges or like flooding issues, like, extreme weather events. Our new material like ultra high performance concrete or high performance steel, they have the potential to address or somehow withstand the potential challenges brought by the climate change. And also we see like, for example, new techniques, right? So for example, our ABC, accelerated bridge construction, they also have the potential to lower the impact of this whole construction process on the outside environment. Right, so this is kind of interaction of these technological factors with the climate environmental factors. And also we've seen, for example, one of our social factors, which we perhaps didn't have a chance to discuss about it in detail, is the safety side of the construction process of the bridges, right? So we have some interview talking about those as well. So safety is a huge concern, right, during the whole construction process for both the, the construction workers as well as for the outside public. And then, then using some of those new techniques, for example, ABC, right? Because you have minimum time out there during the construction process. And then we are really trying to cause less disruption and increase the overall safety of this whole construction process. So that's kind of also this interplay between the social factor and the technological factors. And these are just some kind of simple examples I'm trying to bring up, but we do kind of see this kind of interaction going on among these different factors.
Okay, we're about out of time. I'm going to turn it over to Jugash, and maybe we can pick up one more question. Jugash?
Thank you, Paul. I have a list here of about 3 more, but I think we'll just have to ask one and defer the others for to be answered in a written way later on. First question I have is, will your future study be including other factors such as consumption, growth, population relocation, migration, such as interstate movement, urban to rural, etc.?
Yes, of course. One thing that we really mentioned is reevaluation. It's not only reevaluation of design standards or design codes, but it's also reevaluation of our critical impacting factors. Changes are inevitable, changes are coming, the critical impacting factors that we see as long-term or short-term right now might change to short-term, might change to long-term impacting factors. Long-term impacting factors might not be there in the coming decades. So yeah, we propose that we need to keep re-evaluating of these critical impacting factors in the coming decades, because there's going to be a lot of changes in the coming decades. So if we want to be proactive, if we want to have bridges that are withstanding the climate change that is coming, the sea level rise, all the environmental factors, the economic change, the social changes. So if we need to be proactive, we have to be proactive in this way, that we need to keep evaluating or keep looking out for factors that are out there that might be critical on bridge design, construction, and maintenance. So
Okay,
this is an ongoing process, I guess. This study is our initial study that starts this or encourages researchers, academicians to start this process of finding and discovering critical impacting factors, considering many domains, considering 4 major domains. There might be other domains that are added in the future. So yeah, this is, we'd say that this is our knowledge base. We want to share it, and we want people are, we could do the future studies on these factors and try to find more factors, try to bring in more factors to the table so that we are ready for the future. Our infrastructures are ready to face any kind of challenges that are in the future.
Okay, thank you. There's a few outstanding questions. We'll defer them. We'll answer them on our website. In the interest of time, I must pause this session now for question and answer and turn it back to Mary Lou.
Thank you. Thanks again to Lou and Maruf for sharing your ABC UTC research work at Florida International University, for your thoughtful responses in the Q&A session. That was very helpful. Thanks also to Paul and Jugesh for moderating the Q&A session, to Rachel for managing the web room, and to all participants for your interest, attendance, and great questions. We really appreciate those. Our next quarterly research seminar is scheduled for Friday, April the 29th. Details will be posted on the ABC UTC website as developed. This concludes today's seminar. Thank you so much.